Pressure and temperature. In this video, we're going to talk about gas problems involving only pressure and temperature. If the volume is constant, the pressure of gas in a container is directly proportional to the Kelvin temperature. The formula is P1 divided by T1K is equal to P2 divided by T2K. Remember, the K is there to remind you to work the problem in Kelvin. Gas law problems have to be worked in Kelvin. This is the equation that we will use when solving pressure and temperature problems. For example, what would happen if someone threw an aerosol can in a fire? The volume of the can remains the same, so use the equation with only pressure and temperature. The initial temperature of the aerosol can is 25 degrees Celsius, and the initial pressure is 1.5 atmospheres. The average temperature of a fire is 500 degrees Celsius. What is the new pressure inside the can? First, we're going to write down the knowns from the problem and then the unknowns. P1 is 1.5 atmospheres. T1 is 25 degrees Celsius. We're going to add 273, and that will be 298 Kelvin. T2 is 500 degrees Celsius, plus 273 is 773 Kelvin. P2 is unknown. We're going to rearrange the formula to solve for the unknown P2. The formula is P1 divided by T1K is equal to P2 divided by T2K. We want to find P2, so I can say P2 divided by T2K is equal to P1 divided by T1K. We're going to isolate P2, so I will multiply both sides by T2K. What you do to one side, you must do to the other. Our rearranged formula is P2 is equal to P1 times T2K over T1K. Note that T2K is on the top. Be very careful substituting in so that you substitute T2 in the proper place and T1 in the proper place. Substituting in, P2 is 1.5 atmospheres times 773 Kelvin divided by 298 Kelvin. The unit cancels with a Kelvin, and you end up with P2 is equal to 3.9 atmospheres.